Hi, year 11s, this is Mr. Lim here, and this is our 11th video in the hydrocarbon series about substitution reactions. So let's get started. All right, we're going to be learning about substitution reactions. So let's go. All right, so to form alkyl halides, and that's what we've already talked about, naming alkyl halides, so this is how you form them. Hydrocarbons must react with halogens and be added to the carbon chain. All right, so effectively the halogens are added to the carbon chain. All right, in alkanes and benzene, so that's the saturated hydrocarbons, halogens are added by substituting a hydrogen with a halogen in a reaction called substitution. So effectively swapping out a hydrogen with a halogen. All right, one of the hydrogens on a hydrocarbon is removed and replaced with a halogen. That's what I just said. The hydrogen that was removed is then combined with the remaining halogen, because remember halogens come in diatomic molecules, right, and form a hydrogen halide. What does that look like? Let's have a look. So let's just say we have C, and then let's draw all of these hydrogens out. Okay, so, and then we have a Cl, so that's a Cl2, right? So when this reaction occurs, this one of these hydrogens here is swapped out with one of those. So what you end up with is something like this, where a Cl is now attached where that hydrogen was, and that hydrogen is now attached to the remainder halogen atom, right? And it makes that HCl. Okay, so that's a substitution reaction. Substitution reactions generally can occur in gaseous or aqueous states, and the products will likely be in the same state as they were as reactants. All right. Substitution reactions can occur spontaneously at room temperature if there is the presence of UV light. So if UV light is not there, this reaction will not occur spontaneously. Okay, so you need the presence of UV light for this reaction to occur. All right. The hydrogen that is removed can vary from the hydrocarbons and the halogen being added. But you should be, the hydrogen that is removed can vary for hydrocarbons and the halogen being added. But you should be aware that the different isomers that can be formed from substitution reactions. So what does that mean? Okay, so let's go through with an example. Here I have propane, okay, with 8 possible hydrogens to be substituted. And then let's just have F2, okay? So the idea is that these hydrogens, the 8 of them, if you substitute some of this one here, you're going to produce a 1-fluoropropane, right? But if you substitute this one here, you'll produce a 2-fluoropropane, which means that you can produce 2 different isomers from the same reaction. All right, and so the idea is that you should be able to identify each of these hydrogens here. If it is substituted, then what type of isomer is going to be formed. All right, so let's have a think. If this hydrogen here is replaced, it's going to form a 1, 2, or 3-fluoropropane. Hopefully you should recognize it's still going to be a 1, because if you substitute just that one there, we're going to number it from the other side, and we're going to number it 1 over on this side, 2, 3, right? If you're just substituting one of those fluorines, right? So so these ones here are the ones that will produce a 1-fluoropropane, and then the 2 red ones here will produce 2 fluoropropanes. So if you're going to randomly react this fluorine with the propane, you're going to have the majority of it form 1-fluoropropane, and then the minority of it will be formed will be 2-fluoropropane. Okay, just because the way that it's going to, if it randomly reacts with the hydrogens there, it's going to produce a lot more of the 1 rather than the 2 isomer. Okay, so you're just understanding that it can form 2 different isomers, and then being able to either show that it produces a 1 or a 2, and then just understanding that that's a possibility. All right, depending on the relative amounts of hydrocarbon and the hydrocarbon and the halogen available, the substitution reaction can produce different levels of substituted products. So if the hydrocarbon is in excess, only a single substitution will occur. So effectively, you're just going to remove one of these hydrogens, and replace it with a fluorine. Okay, so that's just one of them. Let's put that in green. Okay, that's just one. If the halogen is in significant excess, all of the hydrogens will eventually be substituted. Right, now this is a bit of a tricky thing, right? So that means that the next fluorine, if I have lots of these fluorines, what's going to happen is that all of these hydrogens will be removed because you've got so many of those fluorines. And then you're going to produce a ton of octafluoropropane. Okay, octafluoropropane because of it all. Right, now just remember that when you have the halogen that's remaining, you never react both fluorines with the hydrocarbon. Only one of the fluorines is going to react with the hydrocarbon and be substituted. The other fluorine must stick with the hydrogen that fell off. All right, so if we're doing this one here, in theory, you would need to have or produce 8 of those HFs for it to be balanced. Right, so really what it would be is C3H8 plus 8F2 would form C3F8 plus 8HF. Okay, so both of the halogens do not get substituted, only one of the halogens. And if you want to do another substitution, you have to get another halogen molecule to do that extra substitution. All right, but that's only if the halogen is in significant excess. If it's somewhere in between, okay, somewhere between the two, a mixture of various levels of substituted alkyl halides will be formed. So effectively, there'll be a range all the way from 1-fluoropropane all the way to a 8-fluoropropane. Just like, a mix of 1s, 2s, 3s, 4s, 5s, 6s, 7s, whatever. Right, with the majority of the 1s and then significantly less 2s and 3s and 4s and 5s as you go along. All right, but that's the idea, that you will have varying amounts. So generally, if they want to create something that has lots of halogens on it, they just have to dump in a ton of halogens to make it in super excess, and then you'll substitute all of the hydrogens. All right, but that's the idea. It's really important to remember that you're always going to produce hydrogen halides, right? Don't think that they're going to just both of them substitute on. You have to remember that only one of them can substitute on. All right, and that's it. Adios.